So let's continue further in our discussion of measure of dispersion. So in this class, we'll discuss about movements. Have you ever wondered how statisticians describe the shape and the spread of a data beyond just averages? So guys, in this session, we'll explore the concept of movements in statistics such as mean, variance, skewness and kurtosis. So you will be able to learn these concepts of movement which give you deeper insight into data distribution and how to use them effectively in research or business. At the end of this topic, you will be able to define the concept of movement and explain its significance in describing a distribution. We'll list down the different types of movements and their corresponding characteristics. We'll explain the importance of movement in statistical analysis. We'll talk about how we can illustrate the relationship between movements and various measures like central tendency, variability and asymmetry.
So guys, discussing about movements. So movements can be defined as the arithmetic mean of the various powers of deviations taken from the mean of the distribution. These movements are also called a central movement. While if the mean is a fractional value, then it becomes a difficult task to work out the movement. In such cases, we calculate movement about a working origin and then change it to movement about the actual mean, where the movement about a origin are known as the raw movement. Now, discussing the formula for the movement for the individual series, like you can see, this is the formula for mu1, where the formula is summation of x minus a by n, or this is also called a summation of d by n. Or if we want to calculate the movement to okay, then it would be summation of x minus a whole square by n, or it is called summation of d square by n. The difference between mu1 and mu2 is that the mu2 is somewhere in the case of mu2, the summation of x minus a, what we consider in mu1, we just took the sum of x minus a, while in mu2, we took the square of the sum. Okay, and mu3, we did the cube summation. Okay, while in mu4, we took the fourth power of x minus a. So in all the mu what we considered the raw movement, either mu1, mu2, mu3, mu4, what we did, we considered x minus a. Okay, and that x minus a in mu1, we just took the summation of that. In mu2, we the square of x minus a, and that summation we divided by n. While in mu3, we took the cube of x minus a, and then we found the average. While in mu4, we took the fourth power of x minus. We took the fourth power. We took the to the power 4 of x minus a, and that we divided by n. Okay, where a is any origin, where d is the deviation of any individual values from the a. Now, for discrete series, the first four raw movement can be mu dash one, where the formula is summation of f d dash by n into c, while the mu two dash is summation of f d dash square by n into square, while mu three dash is summation of f d dash cube by n into c cube, while 4 dash is summation of f into d dash to the power 4 by n into c to the power 4, where d is the step deviation of the values what we did in the first case. Okay, in the same way, we have discussed about step deviation. So by using step deviation, we found this value called x minus a by c for the simplification, where a is the origin from where we just calculated the deviation of each values of x, while c is the common point. Okay, now the relationship between arithmetic mean and movement. Okay, so basically remember this formula when we are working here. So remember this case that whenever we are talking about the relationship between arithmetic mean and movement, remember that mu1 is equal to mu1 minus mu1 equal to 0, while mu2 is equal to mu2 minus mu1 square. while mu3 is equal to mu3 minus 3 of mu1 mu2 plus 2 of mu1 whole cube, while mu4 is equal to mu4 minus 4 into mu3 mu1 plus 6 mu2 mu1 square minus 3 mu1 to the power 4. Now let's discuss few numericals. Here you can see that we want to calculate the first four movement from the given data, where the x and f values are given, where x is basically the values from 0 to 8 and f is the frequency which talks about the repetition of the values of x. Okay, so here what we'll do, like x and f is given to us. Okay, summation of f we did, which tells us the total set of data what we have in the problem. Then we found summation of fx, where we multiplied f into x, and then we took the sum of that. So we got summation of fx, and the end summation of f is 150. Summation of fx is 500. Then we found the step deviation of each value, where we found the deviation of the values of x from any relative value. We call it as assume mean. Let that assume mean is 4. So 0 minus 4, 1 minus 4, 2 minus 4, 3 minus 4, 4 minus 4, 5 minus 4, 6 minus 4, 7 minus 4, 8 minus 4. We can do this, and we got the d value. And then we can do the summation of d value. And then whatever the d value we got, we multiplied with f. Okay, so we got f into d, and that f into d, we can do the sum of that. That will give us 0. Then here, we got this value called f into d, and then what we can do, we can calculate the next value here. The next value what we can calculate here is basically f into d, where f into d square we can calculate, where d square is 16. 16 into 5, it would be okay. 16 to 5, it would be 80. Then again, 3 square is 9. 9 into 10, it would be 90. Then minus 2 square 4, 4 into 15, it will be 60. Okay, so here first we found f into d, then we'll find f into d square. Okay, then f into d cube, and then f into d to the power 4. You can see the correction here. Please correct this slides. There are few mistakes are there, like this is f into d. So the sum of f into d here you got as 0. Then we found the d value what we got. We did the square of these d values, and that we multiplied with f. So we got sum of f of d square. And then the d value what we got, we can take the cube. So minus 4 cube is minus 64, minus 3 cube is minus 27, minus 2 cube is minus 8, minus 1 cube is minus 1, 1 cube is 1, 2 cube is 8, 3 cube is 9, 4 cube is 64. And then we multiplied these values with f, and then we got f into d cube, and then we took the sum of that. So the sum of f into d cube is 0. And then we found the fourth power of d, like minus 4 to the power 4 would be 256. 256 into 15, 256 into f, which is 5, that would be 1280. Then minus 3 to the power 4 is 81. 81 into 10, you will get 810. Then minus 2 to the power 4 is 16. 16 into 15 is 16 to 15 is 240. Okay, then minus 1 to the power 4 is 1. 1 into 20 is 20. Okay. Similarly, so we then when we do the sum of that, so the sum of f into d to the power 4 is 4700. So sum of f into d is 0. The sum of f into d square is 500. The sum of f into d cube is 0. The sum of f into d to the power 4 is 4700. Okay, so here the mean, what is mean? Mean is the sum of fx by n. So the sum of fx, okay, sum of fx we got is 500, and the n is 125. So 500 by 125 will do, we'll get the mean as 4. Okay, and once we got the mean as 4, Then what we did, we subtracted each values of x from the mean. Okay. And then that value, when we divided by sum of d, we got is 0. And that 0, when we divided by the total sum of frequency, we got a 0. Then mu2 would be sum of d square by n. So that is 500 by 125, you'll get 4. Similarly, mu3 is again 0 because sum of d cube is 0. Then mu4 would be 4700 divide by 125, that is 37.5. Another numerical, at the previous numerical, we calculated the movement for the raw data, while if we get a class interval with frequency, then how will we find the mean? How will we find the movement? Let's see with an example. Okay, so here we got the x values where we have the class interval 30 to 33, 33 to 36, 36 to 39, 39 to 42, 40 to 45, 45 to 48. And then what we can do from these class intervals, what is given to us, we can find the mid value of this class interval. That 30 to 33, the midpoint would be 30 plus 33 by 2, you will get 31.5. Then 33 plus 36 by 2, you'll get 34.5. 36 plus 39 by 2, you'll get 37.5. 39 plus 42 by 2, you'll get 40.5. 42 plus 45 by 2, you get 43.5. 45 plus 48 by 2, you'll get 46.5. So you got the mid values. Okay, once you got the mid values, and then frequencies are given to us, okay, for each class interval. Okay, then what we can do, we can find the total sum of frequency here. So the total sum of frequency is 100. And then we can find the step deviation where uh, out of this m value, we took any arbitrary value or assume value. Let that assume value is 37.5. So each m value, when it subtracted from 37 uh, 0.5, okay, when it's subtracted from 37.5, and it is divided by 3 by 3 because 3 is the class width. Okay, so you 31.5 minus 37.5, you'll get a minus 6. Minus 6 by 3 is minus 2. Okay, then 34.5 minus 37.5 is minus 3. Minus 3 by 3 is minus 1. Okay, similarly, when you do this calculation, you'll get the d value as minus 2, minus 1, 0, 1, 2, 3. Here, remember, there's a small mistake in the slide. The d is equal to m minus 37.5 by 3. Okay, here it's written as 37.7. So correct it. It is d is equal to m minus 37.5 by 3. Okay, then once we found the d value, we multiply the d with f. Okay, so we got f into d, and that f into d, when you do the summation, okay, so here the sum of f into d, here when you do, okay, so we got an value here. Okay, here f into d, 3, 2 into 2, 2 into minus 2, minus 4, 4 into minus 1 is minus 4, then 26 is 0, 47, then 30, then 18. So when we'll do this calculation, this is not 0. This will come as 47 plus 30, 30 plus 18, 30 plus 18 is 48, 48 plus 47, 48, 1 minute, let me open a calculator. 47 plus 30, okay, plus 18, okay, you will get 95. 95 minus 16, okay, 79. So here, the value what you're getting as sum of FD, you're getting as 79. So here the sum of FD is 79. It is not 0. Okay, you can correct that. Then d square, the 2 d square, 2 square is 4. 4 into 2 is 8. Then this is 1. 1 into 4 is 4. Then you will get 0. Then 47. Then 4 into 15, 60. Then 3 square is 9. 9 6 are 54. Okay, then you can do the sum of this. So if you do the sum of this, 8 plus 4, 12, 12 plus 7, 12 plus 7, 19, 19 plus 4, 19, 23, 23 plus 2, 2 carry 10, 10, 15, 17, 173. This is correct. Similarly, we can find sum of FD is 79, sum of FD square you get is 173, sum of FD cube you are getting as 309, then sum of FD to the power 4 you are getting as 809. Okay, so each values summation we can find, and then we can apply them in the formula. Okay, so here we can say that mu1 is equal to sum of fd dash by n into c. The n is the total sum of frequency. N is equal to 100. Okay, so the total sum of fd, sum of f into d. Okay, when we calculate here, c is the class width here. So c is the class width. So when we see the class width according to this class, so the class width is 3. Okay, so the class width is 3. So 87, 79 Kriza this is 21, 237. Then 87 Kriza, if I do, this is 261. So the sum of FD dash is 87 and the C is 3 and N is 100. So 87 3 is 261. 261 by 100 is 2.61. Mu1, then mu2 dash is summation of FD square by N into C square. So summation of FD square is 173 and C is 3. 3 square is 9. So 173 9 is 1557. Divide by N. N is 100. You'll get 15.57. Then mu3, you have to find sum of FD cube into C cube by N. So FD cube is 309 into C is 3. 3 cube is 27 by 100. When you solve, you'll get 83.43. Similarly, mu4, sum of FD to the power 4 is 809 into 81 by 100. When you solve, you'll get 655.29. Okay, so the movement about mu1 would be equal to 0. Mu2 is equal to mu2 minus mu1 square. So here the mu2 we got as 15.57. Here mu2 we got as 15.57. Mu1 is 2.61. So here when we calculate, so mu2 is equal to mu2 minus mu1 square. Mu1 is 2.61. Mu2 is 15.57. When we solve, we get the value of mu2 is 8.76. Then mu3 we can calculate. Mu3 value already calculated. Mu1, mu2 we calculated. Okay, so we just put them in the formula. Okay, what we have calculated in the previous calculation. So the mu3 we get minus 2.91. Then mu4, similarly we have calculated the value of mu4, mu3, mu1, mu2. Everything will substitute in this formula and we'll get the value of mu4 as 291.454.
In let's summarize the concept what we have discussed so far in this session. When it comes to movements are the quantitative measures that describe the shape of a data or a data distribution. Okay, movement provide insights into key characteristics like central tendency, mean, dispersion, or spread like variance. It talks about asymmetry like skewness and tailoredness like kurtosis. When we talk about movements, the first movement represent the mean. The second movement, it represents what? Variability. The third movement identifies the asymmetry of the data. And the fourth movement highlight the thickness of the tail. The movements are essential for understanding and summarizing complex data set, offering a comprehensive view of the distribution. They also serve as a foundation for advanced statistical analysis, aiding in decision making and predictive modeling. So I hope you have understood the concept of median. So I hope you have understood the concept of movements what we have discussed in this class. So with this we are in the end of the unit 3, which is about measure of dispersion. So I hope you have understood all the key measures what we have discussed. Either it was range, either it was mean deviation or quartiles deviation, or it was standard deviation or variance or movements. So it's time to wind up this session. Thank you everyone. Happy learning.